All right. It is time for your test review. Unit 5B, Polynomials. It is February 2023, just in case I replay this video another time and don't have to redo it. So this is what your review looks like. And then we're going to go through this. I'll probably do this in at least two videos, two different videos. I'll do half or a little more than half in this video and then the rest in another one. All right. Here we go. Y'all ready for this? All right. So we are subtracting polynomials. Polynomials means that we have more than two terms in each of them. So poly means many. So we have more than two terms because two terms is a binomial. This is a term, this is a term, and this is a term. So we have three terms in the first parentheses, and we also have three terms in the second parentheses. When we do these, I like to put them in columns by their like terms. When I say like terms, I mean everything with an x squared is a like term, everything with an x is a like term, and everything that's a number that doesn't have an x, just a regular old number, that's a like term as well. So let's put them in columns. Let's put the x squareds in one column. Let's put the x's in another column. And then let's put the numbers in another column. We're going to go across the top and write them just as we see them. 7x squared, 3x, and then minus 12. Now, because we are doing subtraction, there is a different rule when we do subtraction. So think of subtraction as same, keep everything in the first parentheses the same. We're going to change the subtraction to addition, and then we're going to change all, which means we're going to change the signs of each and every number in the second parentheses, and we're going to line them up. So this 2x squared over here, when we put it in the x squared column, we're going to change the sign to a negative 2x squared. This 5x over, this negative 5x over here, we're going to make a plus 5x. And this negative 19, we're going to make a positive 19. And it said we're going to add them because we're going to change the subtraction to addition. So 7x minus 2x is going to be, 7 minus 2 is going to be 5. When we're adding like terms, we do not change the x squared. We don't add the 2's, okay? The squared. That just stays x squared. 3x plus 5x, 3 plus 5 is 8. The x comes down, we don't change the x. And negative 12 plus 19, or you can think of this as 19 minus 12, that's going to be 7. So your answer is going to be 5x squared plus 8x, and that's a plus 7. By the way, if I get anything wrong on here, just give me a heads up so I know to fix it. All right. Let's go down to number 2. Number 2 is actually a little easier. It's the same exact thing, but it's a plus in the middle. In this case, we do the same thing with the columns. We have the columns for the x squared. We have the columns for the x's. And then we have the columns just for the regular old numbers. And we're going to line up the like terms. In this case, we across the top, nothing changes in the first and nothing changes in the second either because we are doing addition now. So 3x squared minus 12x minus 15. And just like you see them in the second parentheses, we put them in the columns. Negative 2x squared, this is the x squared column, plus 3x, and then plus 14. And we're going to add them up. You do this on your calculator. You don't change the x squared. 3 minus 2 is 1. X squared. You don't have to put the 1 in front, but you can if you want. This is negative 12 plus 3, or 3 minus 12. My answer is going to be negative, and it's going to be negative 9x. And over here, negative 15 plus 14 is going to be negative 1. Make sure you have a calculator to do these if you're unsure, if you're not 100%. So our answer is 1x squared, or just x squared, minus 9x minus 1. All right, multiplying polynomials, okay? Multiplying polynomials. These are binomials, really, because they have two bi. The root word bi, like bicycle has two wheels, means two. So these have two terms. This is term 1. This is term 2. Same thing in the other parentheses. So when we do these, we taught you a couple of different ways. You can distribute or you can do FOIL. Now, I think some people do get confused with the FOIL. So let's do the distribute first, and then we'll do the FOIL next. I'm going to rewrite this to get a little more room down here. 2x minus 1 times 5x plus 4. Now, when we distribute, we are taking the first number and we are multiplying it with each of the terms in the second parentheses. So let's do that. We have 2x times 5x. 2x times 5x, 2 times 5 is 10. And then x times x. When we multiply with exponents, this is a ma. I think of it as ma. Exponents have specific rules, and exponents have different rules. When they want you to multiply exponents, you really have to add them. So this is going to be x to the second power. So when we do 2x times 5x, we get 10x to the second power. We have to distribute the 2x into the 4 now. 2x times 4 is plus 8x. So we're done with that first one that we distributed. Now we have to take the second one, which is a negative 1, and we're going to distribute that into the 5x and into the 4. Negative 1 times 5x is minus 5x. Negative 1 times a positive 4 is going to be negative 4. Now we're going to combine like terms. We do have like terms in the middle. And when we do this, do not multiply these. You add these. So this is going to be 8x minus 5x. 8 minus 5 is 3. And you just bring down the x. When you add or subtract with the x's, you do not change them. It stays as an x. So our final answer here is going to be 10x squared plus 3x minus 4. If you did the FOIL method, okay, I know Mr. Lynch's class did a lot of foiling with that, and I learned that myself. So let me rewrite this, and let's talk about the FOIL. 2x minus 1 and 5x plus 4. First, outer, inner, and last. The first means I'm going to just put a plus in the middle of one and a minus in the middle of the other. Now, it doesn't matter what I put here. I just want to show you. Actually, it doesn't matter, but I will change that to a minus because I said I was going to do a minus in the second one. So we have a plus in the middle of the first binomial, a minus in the middle of the other one. Don't get this confused with the difference of squares that we're going to do later. So I just want to show you the positions of the first. The first means these spots here, which is 2x and 5x. Those are the first because they're the first in the parentheses. So these are first. So if you multiply first times first, that's going to give you the 10x squared. The outer is going to be the outsides, these two. So the outer would be the 2x and the 4. Those are the outer. So these are also the outer. And then the inner are going to be the opposites of the outer. They're going to be here on the inside. Those are inners. So you would multiply those two next. And then the last means the last two in each parentheses, the last one in each parentheses. This is the last in this parentheses. This is the last in that parentheses. So this is last times last. So if you follow the first, outer, inner, last, the FOIL, that's the order in which you do it. Again, you would combine like terms at the end. All right. This one looks a little more difficult, but it's really not. What are we doing with -3 and then this first parentheses and then this second parentheses? Anytime in math, when you have things smushed up against each other, that means we're going to multiply. So we're going to multiply. Also in math, it doesn't matter what order you multiply in, because if you did 7 times 5, you're going to get the same thing as 5 times 7. All right, Teddy, I can't have you barking here. Yeah. Okay. So let's multiply this -3 into this first parentheses first. Don't worry about this second parentheses right now. Okay. Do not worry about this right now. We're going to worry about it a little later. So let's distribute this -3 into this first parentheses. -3 times x is -3x. -3 times -12. A negative times a negative is a positive. 3 times 12 is 12, 24, 36. Okay, so we took care of that. Now we're going to have to multiply it with that second parentheses. And this is going to be just like we multiplied before now, like a FOIL method if we want, or distribute. If we did the FOIL, we would do the first times the first, which is going to be 3x times -3x times 3x, which is a -9. -3 times +3 is -9. X times x, x squared. The outside, we're going to have the outside, it's these two. Those are the two on the outside. -3 times a +4 is going to be -12 with an x, because it's -3x. The inside, we're going to have these two are the insides. We have 36 times 3. I don't know what that is, so I'm going to get my calculator out. 36 times 3 is going to be 108. So we have a plus 108 with an x, because that's a 3x times 36. And then our last is going to be our 36 times 4. That's going to be our last. And what is that? Calculator, 36 times 4 is 144 plus 144. That's a 4. Do we have like terms? We do. Those middle two terms are like terms right there. So we have to combine like terms. That, again, we're adding when we combine like terms. 108 minus 12 is going to be 96. So that middle just becomes 96 over there. So it's -9x squared plus 96x plus 144. All right, we're going to number 5. Number 5, if you look at this, you can see that the first parentheses is exactly the same as the last parentheses, except one has a minus and one has a plus. So we're going to have something different in this answer here. It's going to be a little bit different when we find the answer, and you'll see why. Maybe some of you guys know it already. But we're going to FOIL. First times first, 3x times 3x. 3 times 3 is 9. X times x is x squared. The outside, 3x times 5. 3 times 5 is 15 with an x. The inside, -5 times 3 with an x. It's -15x. And the last is -5 times +5, which is plus 25. Hold on. Let me just shut the blinds here. Get down. 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 Go down. All right. So if you notice in the middle here, when we combine like terms, -15 plus 15, those are going to be 0. 0 is going to cancel out. So they are gone. We don't need them. Don't want them, don't need them. So we have 9x squared plus 25 is going to be the final answer there. Number 6, anytime you square something, what do you do with it? So if you had 5 squared, how would you do 5 squared? What would you do in your calculator if you had 5 squared? You would do 5 times 5. Make sure it's not 5 times 2. If you had 10 squared, you would do 10 times 10. If you had x squared, you would do x times x. If you had 4x squared, well, the whole thing would be 4x times 4x. If you had x minus 12 squared, which is what we have here, you're going to do x minus 12 times the same thing, x minus 12. When you square something, you times it by itself. So we do the FOIL now. Now this is not like the last one because this has the same exact thing in both parentheses. The last one, it had a plus in one and a minus in the other, and the middles canceled out. The middles are not going to cancel out here. You're going to have to combine them. So we get x times x, x squared, negative 12 times x, negative 12x. We're going to do the inside now. Negative 12 times x, again, negative 12x. And negative 12 times negative 12. A negative times a negative is a positive 144. We combine these guys in the middle. We get x squared, a negative plus a negative. If you wanted to do it in your calculator, you would do negative 12 minus 12, or you can do negative 12 plus a negative 12. I do like to do parentheses sometimes with my negatives, especially if I'm going to add them. Either way would work. When you add two negatives, you're just going to get a bigger negative. I guess I should write negative. Negative 24 with an x plus 144. And that's how you do number 6. Number 7. We are going to distribute. This looks like it's going to be a lot of work. It's not that bad. You just have to take your time. Can't think of the FOIL when we do this one. The FOIL is only when there's two terms, one term, and there's two terms in another parentheses. But we have two terms and three terms. So this one we're going to do straight up distribution this time. So let me get those off. Straight up distribution. We're going to take the first one and we're going to multiply it into each of the terms in the second parentheses. Let's do that. And it's important to keep your columns here. All right, we got one. I think we're going to have 4 columns on this one. You will have 4 columns on this one. First, 5x times 3x to the second power. 5x times 3x to the second power. Let's look at the numbers. 5 times 3, 15. Now we do x times x to the second power. We're multiplying with exponents. That's a ma situation. When they want you to multiply them, you really have to add them. So this is x to the first plus x to the second. That's going to give you x to the third. Next, 5x times negative 12x. Well, 5 times negative 12 is negative 60. X times x, it's 1 and 1, which equals x to the second. So this is negative 60x to the second power, or x squared. Next, we have 5x times negative 2. 5 times negative 2, negative 10 with an x. Put an x there. All right, let's go to the next one we're going to distribute. The negative 12 we have to distribute. So when we distribute the negative 12, we get negative 12 times 3x. 12, 24, 36. A negative times a positive is a negative. So we're going to get negative 36 x squared. We have to bring down the x squared. There's no x in the 12. The 3x squared, we have to bring down the x squared. Negative 12 times negative 12. Negative times a negative is a positive 144. Negative 12 times 1x is just going to bring down 1x. And negative 12 times negative 2 is a positive 24. So we're going to add up the columns. Add the like terms. I don't know why that keeps coming up. I apologize, but don't know why. 15x to the third. Let's add these up. That looks like it's going to be negative 96x squared 144 minus 10 is 134. That's a plus 134x and then plus 24. We are doing number 7. I just want to make sure I got it right because I did these before. We have 15x to the third minus 96x squared plus 134x plus 24. We have a bingo, or we are correct here. So this would be your answer. You would put this all together as your answer without the lines in between. Oh, these are fun. I love these. I'm sure you guys do too. All right, so we are factoring these. We are factoring these out. So we have to find the greatest common factor of the numbers and also the greatest common factor of the letters, okay, the exponents. So let's look at the numbers first. 12, nope, didn't want that. Don't know what that is. Okay, so we're going to do a little highlighting. Let's get that eraser though first. All right, let's highlight. Let's highlight the 12 and the 2. Don't worry about the negative right now. The first number is positive, so we're going to take out a positive GCF. We're looking for the GCF, the greatest common factor of 12 and 2. Be right back. Just closing the door here. All right, so we're looking for the greatest common factor of 12 and 2. Now, factors are all the numbers that multiply into the number. So factors are 1 and 12, 2 and 6, 3 and 4. 5 doesn't go into 12, and then 6 we already used, so we're done. And the only factors of 1 and 2 of 2, are 1 and 2. So which is the greatest common? Which is the one that they have in common and is the biggest number? So it's going to be 2. 2 is going to be the number GCF. It's going to be 2. Now let's look at the letters here. Let's look at the letters. We have x to the 13th, x to the 13th, and x to the 4th. We have to ask, does the first term, this is term 1, and term 2, do all the terms, in this case we just have 2 of them, do all the terms have an x? If we answer yes, all the terms have an x, then we know that x is our GCF. But now we have to figure out what power is the GCF. Well, this one has 13 x's. It's a lot of x's, but I'll go through the process. X, 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 x. I think that's 13. This one has 4. 1, 2, 3, 4. Well, how many do they have in common? They have 4 in common, okay? They have 4 in common. So your greatest common factor is going to be x to the 4th. Now, it's always going to be the smaller number that you have. Let's look at the y's here. We have y and we do not have a y in the second term. So y is not a GCF. We cannot take out a y as our GCF. It stays up there, but we don't put it down here because this is our GCF here right now. Let's look at the z's. We have a z4 in the first term, and we have a z to the second power in the second term. Now, it's going to be our smallest one, which is going to be z to the second power. All right. So then we're going to start a parentheses here. And we're going to divide each of the terms by the GCF. So we have our GCF. We're going to divide the first term by the GCF and the second term by that same GCF. All right. When we divide, I think of this as a Nintendo DS. We had the ma. When you multiply, you add exponents. But when you divide, you actually subtract the exponents. So x to the 4th divided by x to the 3rd, x to the 13th divided by x to the 4th, we are going to subtract 13 minus 4, and we're going to get x to the 9th. I didn't do something before. The numbers I have to do, though, first. 12 divided by 2 is 6. 13 minus 4, we are subtracting the exponents. With the 12 and the 2, we do not subtract 12 and 2. Those are real numbers. That's really 12 divided by 2. Treat real numbers like real numbers. 12 divided by 2 is 6. 13 and 4, they want you to divide those exponents, but you really have to Nintendo DS them. They want you to divide. You subtract. This y, I don't have a y that we're dividing by, so I have to bring down the y. Z to the fourth divided by z to the second. Z4 divided by z to the second. We subtract 4 minus 2, and we get z to the second power. Let's go to the next term. Negative 2 divided by positive 2. Negative divided by a positive is negative. Negative 2 divided by 2 is 1, so that's going to be negative 1. X to the fourth, 4 minus 4, x, 4 over x4 equals x to the 0 power. And anything to the 0 power is equal to 1. I do not have to put a 1 here, because it would be, if I did, it would be multiplying by 1. Negative 1 times a positive 1, it stays. Same thing, doesn't change. So anytime you have a fraction with the same thing on top as you do on the bottom, you see everything on top is the same as everything on the bottom, then you would need to put a 1 there. In this case, it's a negative divided by a positive, so it's a negative 1. Hope that wasn't too confusing. All right, we have to find the GCF again. We have numbers. We're going to look for the GCF of these numbers, 50, 48, and 60. Do not worry about the negative here. If the first number is negative, we do take a negative out and use it as a GCF, but in this case, that 50 is positive, so our GCF is, the number for our GCF is going to be positive. 50, 48, and 60. Now, I know only 2 can go into each of these, because 48 and 50, there's nothing that can go into both of those except 2. And 2 also goes into 60. So 50, 48, and 60. There is a fancy way. If you have the fancy calculator, there is a way to find the GCF on your, if you have a TI 84, you would do math, and you go across to number, NUM, and then you press the number 9, and then you would have to do it again right away. Math, you go across the number, and you press the number 9. You would put in your first number, comma, your second number. You do not have to do negatives. You close the parentheses. You would hit comma, and then the third number, and then you would hit enter. And it would tell you that the GCF is 2. If you were just looking for 2 numbers, okay, this is a 3 number GCF, you have to do it this way. If you were just looking for 2 numbers, you would just do math number 9. You would hit math, that's a button that says math. You go across to number, NUM, you press the number 9, and if it was just 2 numbers, there's a parentheses that's there already. You would do the first number, comma, the second number. You don't even have to close the parentheses, and then hit enter, and it would tell you there. All right. So we know our GCF is 2 for the numbers. Now let's see what the letters are. All right, let's look at all the terms. Term 1, term 2, term 3. Do all the terms have an x? Yes, yes, yes. So we know we have an x as our GCF. What's the smallest x? When I say smallest x, I mean which exponent is the smallest? 3, 2, this is a 1 we can put here. So it's just x or x to the first. Let's look at the y's. Do they all have a y? Yes, yes, yes. The smallest y we're going to use, which is just y. So now we're going to divide each of these terms by our GCF. $50 divided by 2xy, 48, negative 48 divided by 2xy, and it's everything on top divided by 2xy, and everything on top divided by 2xy here. All right. 50 divided by 2, we have to start our parentheses. 50 divided by 2, that's a real number. We do not subtract these. Real numbers we treat like real numbers. 50 divided by 2 is 25. Now the exponents, that's a Nintendo DS situation. Okay? 3 minus 1 is going to be x to the second. Same thing with the y's. 3 minus 1, y to the second. Now we have negative 48 divided by 2. A negative divided by a positive is a negative, negative 24. 2 minus 1 is just going to be x to the first power, or just x. 4 minus 1 is going to be y to the third power. Next, 60 divided by 2 is going to be a positive 30, and the x's we don't need, and the y's we don't need. And that's going to be that. All right, last three before we take a break, because I think we're going to be about halfway there after this. So with these, you have to recognize something. If you have these with a minus in the middle, you have to ask yourself, you say, self, do we have perfect squares going on here? Are these a difference of perfect squares? Let's talk about what a perfect square is. Let's list all the perfect squares here. All right, we'll list them at the bottom. Is 1 a perfect square? Yes, it is, because 1 times 1 is 1. Is 4 a perfect square? Yes, because 2 times 2 is 4. The next is going to be 9. 3 times 3. The next is going to be 16. 4 times 4. I'm just going to keep going. 25, 36, 49. That was 7 times 7. 64. 81, 100. I'll go two more. 121 and 144. So that's all the way up to 12. 5, 6, 7, 8, 9, 10, 11, and 12 times 12. Okay, so those are perfect square numbers. Okay, let's talk about exponents, perfect squares. All right, is x to the second power a perfect square? Well, it is, because x times x, remember, we add the exponents, equals x to the second. Is x to the fourth power a perfect square? It is, because x to the second times x to the second equals x to the fourth. Is x to the sixth power a perfect square? Well, the number 6 is not a perfect square, but x to the sixth power is, because x to the third times x to the third, remember, Ma situation, 3 plus 3 equals 6. So with the exponents, anytime you have an even number exponent, anytime you have an even number, x to the 8th, x to the 10th, x to the 14th, x to the 30th, all of these are perfect squares, because x to the 8th is x4 times x4, 10 is x5 times x5, 14 is x7 times x7, 30 is x15 times x15. Half of 30 is 15, half of 14 is 7, half of 10 is 5. Okay, so we're taking a look here. Is 16 a perfect square? It sure is. Is x squared a perfect square? Sure is. Is 25 a perfect square? It sure is. And do we have a subtraction sign? Is there a subtraction sign between them? Do we have a difference? Difference means subtraction. A difference of perfect squares. We do. When this is the case, that's when you just throw your two parentheses in there. You put a plus in the middle of one of them. You put a minus in the middle of the other one. Now, I could put a minus in the front and a plus in the back. Sorry about that. I could if I wanted to, but I don't have to. All right, so what goes in the front of both of these parentheses? Well, let's take a look here. At the front of both of these parentheses goes, darn it, goes the square root of 16 and x squared. The square root. What's the square root of 16? What times what is 16? Same number it has to be. 4 times 4 is 16. What times what is x squared? X times x is x squared. You see how the 16x squared is before the subtraction sign? Well, before the sign, at the beginning of each of these parentheses, has to be the 4x. Now, whatever the square root of 25 is, has to go to the back of the parentheses. It has to go in this spot over here. So square root of 25 is 5. So that's what we put in the back. All right, let's hit number 11. In number 11, I don't know how much we did something like this, but we don't have a plus in the middle and we have a minus at the front. If you see this, and again, I don't know how much of this we did in class, so pay attention in case this is on your test. We are going to take out a negative. We don't want a negative at the beginning, so we're going to divide by a negative 1. Okay, we're going to take out the GCF, negative 1 parentheses. Negative 49 divided by negative 1 is a positive 49 x squared. Okay? Positive 49. Negative divided by negative is positive. Then we have 100 divided by negative 1 is going to be negative 100. So now we take a look. Is 49 a perfect square? Yes, because 7 times 7 is 49. Is x squared a perfect square? Yes, we already knew that. And is 100 a perfect square? Yes, because 10 times 10 is 100. So when we see all perfect squares and a minus in the middle, we are going to do 2 parentheses, plus in the middle of one, minus in the middle of the other. At the beginning, we have to put whatever's at the beginning here. When I say beginning, I mean before the sign. So at the beginning here, before the sign, the square root of 49 is 7. That goes at the beginning of each. The square root of x squared is x. That goes at the beginning of each. Square root of 100 goes at the end. That's going to be 10 and 10. So that is your answer. Make sure you bring down the negative 1 over here. That is your answer there. All right. Every time we do these, the first thing we have to look for is a G, C, F. So if you look at this and it looks like the others and you say, well, 75 is not a perfect square and 12 is not a perfect square, then we have to start thinking, do we have a GCF? So if you did it on your calculator, okay, you would do math. You go across to number, NUM, you hit 9, 75, comma, 12, enter, and you would get a GCF of 3. Otherwise, you have to figure out the GCF yourself. 12 and 75. So we have to figure out all the numbers that multiply to 12. 1 times 12, 2 times 6, 3 times 4. What's the biggest number of these that also goes into 75? You might have to take a little time and you would figure out that it's 3. 3 is the GCF. X is not a GCF because we don't have an X in the second term. So just the GCF is 3. So if we divide by 3, 75 divided by 3 is 25. X squared comes down, x squared. Negative 12 divided by a positive 3 is negative 4. Now, do we have perfect squares going on here? Is 25 a perfect square? Sure is. Is x squared a perfect square? It is. Is 4 a perfect square? So we have a difference, subtraction in the middle, of perfect squares. So we have 3 as our GCF. We have 2 sets of parentheses. We're going to put a plus in the middle of one, a minus in the middle of the other. The square root of 25 goes at the beginning of each. So it's going to be 5. The square root of x squared also goes at the beginning. X times x is x squared. And then at the end, the square root of 4 is 2. So that is your answer. All right. I think we are halfway there. So we are going to take a break. We're going to go to video number 2 now that we're halfway there. See you soon. If I can figure out how to stop this video, and I will.